Hello everybody, another Henstitute help session here. So this is actually for the MegaWork concepts number 5, 6, and 7. I didn't actually put the problems, but I'm going to kind of help you how to figure this out. So the idea is we have some block up here, which has a mass m. It has an initial velocity of vi, initial height of hi or h. And as it shows, the block is going to slide along, go down this ramp, and then come over here. It's going to enter friction right there, so it's basically going to slide until it comes to a stop right there. That's kind of the idea, and then we have a distance here. So this threw some people off. It mentions that descends through a distance h. You can say descend through a distance, height h, whatever. I was just kind of using their general idea. So in question number 5, they talk about, okay, what if you change the height of this? What if this is changing? How would that affect D? So really what I'm looking at here is that if I kind of borrow the entire MegaWork, we start out with gravitational potential energy and kinetic energy up here. And we're going to have zero work happening during this part. And then over here, we're going to have work done by friction. So as I kind of look at the whole thing, I really have work done by friction is going to equal a change in my gravitational and a change in my kinetic. But we don't have to worry about elastic materials, and we can have that. We're going to end up at the lowest point, so our final gravitational potential energy is going to be 0, and our final kinetic energy is going to be 0 because it's going to come to a stop. So really what I have over here, normally we'd have minus the mugged equation, but since we're dealing with the final situation here, I'm going to put a big D because that's what this is written as. So I've got the mugged equation, but here I would normally have mghf minus mghi, but the hf is 0. So I'm just going to write it's mgh. So you just have mg, which technically I guess it's mghi. And then over here, kind of same with the kinetic energy, we have 1/2 m times, this would be the initial velocity squared. So this is kind of what we have going on. So this would be the equation. If I knew all the values, I could find them and that type of stuff. So question number 5, they talk about, okay, what if you change height? How does that affect D? So for that, we're going to ignore the velocity. The velocity is not changing, so this is kind of irrelevant. And what you find is that in number 5, that height is directly related to distance. So if this goes up, the distance is going to go up by the same amount. So if this doubled, this would double. If this went down by a factor of 2, this would go down by a factor of 2. So that should allow you to answer that one. It's pretty straightforward. It's kind of nice. Number 6 talks about how is velocity related to distance. In other words, if this thing was going faster or going slower. So if I pull out that part, what I find is that v squared is directly related to the displacement or the distance it travels. So again, if we increase this, the distance is going to increase. Obviously, if it's going faster, it's going to slide to a greater distance. But since it's that squared situation, if we doubled the speed, we would actually see 4 times the distance. And just the reverse, if we were to cut the speed in half, we would actually see this become decreased by a factor of 2 squared. For fourths, basically it would be 1/4 as big, because this would be like 1/2, just like this would be 1/2, and this would be 1/2, whatever. So that's that idea. 7 is talking about mass. Here's the key thing. Since we don't have elastic materials, notice what happens to all the masses. Bye-bye mass, bye-bye mass, bye-bye mass. So actually mass is irrelevant. It does not actually matter what this mass is. They would all slide to the exact same distance when it comes to a stop. Hope that helps on number 5, 6, 7 in this Henstitute Help.